Topic 15, triangle inequalities. I'm going to cover questions number 3, 7, and 8. I'm going to start with question number 3. Determine which of the following could not be lengths of a triangle, sides of a triangle, explain or justify. Okay, so triangle inequality theorem states that a triangle the sum of the lengths of any two sides of a triangle must be greater than the length of a third side of a triangle. Seven is already set up here at 12, 13, and 25. So starting with the first problem on 3A, I'm going to go ahead and set up all three inequalities. All three of these are true, so therefore we know that we have a triangle using all three of these sides. Okay, so can be a triangle. Now, you can remember though from our notes, we don't actually have to check all three of these each time. To determine whether a triangle is possible, we must really only compare the shorter two sides to the longest side. Once again, we must only really compare the shortest two sides to the longest side. We're doing that right here. This is really the only inequality we need to look at in order to see whether it was true. It is true, so we can quickly just jump to the idea that yes, this in fact can be a triangle using these three side lengths. I'm going to go ahead and use this on the remaining three examples, just using the shortcut version. So, taking a look at 3b, 1, 1, and 3. In order to determine whether a triangle is possible, I must compare the shorter two sides to the largest side. So, I must know that one in order for this to be a triangle. 3, that is not true. False. Therefore, not possible to be a triangle. And if we actually tried to draw a picture of this triangle with 1, 1, and 3, if I drew side length of 1, 2, 3, since biggest 3 is my biggest side, and if I tried to take these two shorter pieces of 1 and 1, well, there'd be no way for me to actually put these together or have create another vertex and actually have a triangle. So physically we can see that, but here's the amount of math that I would need to do to verify that it is not a triangle. Okay, I'm going to go ahead and compare the shorter two sides to the longest side. Go ahead and show that 6 plus 6 is greater than 7 in order for it to be a triangle. 12 is greater than 7. This is in fact true, so therefore this can be a triangle. I like this. Okay, 3D, compare the shorter two sides. The shorter two sides, 12 and 13, with my longest side, 25. So setting up the inequality, 12 plus 13 must be greater than 25. 25 greater than 25. This is false. 25 is not greater than 25. It's equal. It's not greater than. So therefore this cannot possibly be a triangle. Okay. Now, going back up to question number 7. 7 and 8 are very similar. We're not determining whether it could be a triangle like in 3. We're actually determining the range of values for a possible third side. Okay, so to figure out the range of values for our possible third side, we must remember that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay, well, let's imagine that, in terms of solving this particular problem, that we know that 16 is in fact the biggest side. Well, my inequality then, my unknown stuff for that plus 11 must be greater than of 16. And we're going to subtract those two values, and we must know that x must be greater than 5 if in fact 16 our biggest side. Well, the other case we need to think about is what if x is in fact our biggest value? Well, in that case, side lengths of 11 plus 16 must be bigger than our third side, which is x, the largest side in this case, in this theory. So really what that means is that 27 must be greater than x. So the biggest that x could be is in fact 27. All right, putting these two values together then, we're going to write it as a compound inequality of 5 is less than x, which is less than 27. Once again, this kind of models what we were doing in class in terms of the kind of shortcut way to go about doing this. If I want to find my range of values, which x is between, we have a high bound, a low bound. The low bound comes from simply subtracting the values, and the high bound comes from adding the values. Okay, and you can kind of see that we did that. We subtracted our two values, imagining that x is one of the smaller sides, and we added the values when we actually figured out or thought about x as being the biggest side in our triangle. So once again, we subtracted 16 minus 11, which also gave us 5. And here, if I added them together, that would give me 27. Okay, moving on to question number 8. Triangle ABC has sides AB equals 18, BC equals 26. Identify the possible values of AC. Okay, I'm going to start off by drawing my triangle. I want to figure out the possible values of this side AC. I'm going to go ahead and use my idea of low bound and high bound. So for the low bound, I'm going to subtract my values. This again is assuming that 26 is the biggest side of my triangle. So that would be 26 minus 18, which gives me 8. I'm trying to figure out what the range of values is for this possible x. So my high bound comes from the idea, if I'm adding my values, that comes from the idea of, well, what if x is in fact the biggest value of the triangle, the biggest side of the triangle, so that means I have to go ahead and add my two sides to make sure it can't be bigger than that. So in this case, we're going to add 18 plus 26, which is going to give us 44. So in terms of writing this as an inequality, 8 is less than x,